Hello everyone, welcome to the next lecture on the CSIR NET Mathematics July 2024. Today I will explain you how you can solve the real analysis questions from the part C. Myself Dr. Harish, you can follow my YouTube channel where you can find the complete solution of the July 2024 under the playlist of CSR UGC NET. And you can see I have completed all the complete solution of the July 2024. So that's why this is my last lecture on this July 24 solution. You don't forget to subscribe my YouTube channel. Once you watch my these complete lectures, then your reaction will be changing from off to the wow. What you can call as a off is whenever you will see the question, you are unable to understand it, but after watching my these all lectures, your reaction will be changed and you are able to understand how you can tackle the question in a simple manner. Once you can tackle your question, then your examination will be qualified in a simple manner. Now, first question is a sequence. Always remember, if you look about that, this question is a very confusing for you. Believe me, this is the easiest question. What you have learned from my previous lectures, as I told you, whenever you have a sequence, you always think to start your problem by consider any one of the sequence from here, either the constant, either from the n or from the sign of the n. Now look at that, it's a sequence of the positive number, so this is not satisfied this condition. Constant satisfied, n satisfied, sign n is satisfied. Fine. So I can take on these three counter examples and then we can prove easily. So let's start with this. If I choose an is my 1, is a constant, then what will happen of the bn? Bn will be 1 over maximum is my 1, that is my 1. So this case will be satisfied. Limit of the an existence. So that means, because we all based on the one example, you can't correct the option. An is bounded, that's fine. Now you can see an is bounded. Is there anyone which is unbounded? Only this case is my unbounded. Fine. So if I start from the an is my n, then what is the maximum of the ai's? A1, A2 is a 2 up to an. So the maximum is n. So what does it mean? What is the bn? Bn is my 1. Fine. So this case will satisfied. Is the limit of the an existence? No. Is the an is bounded? No. So first and the second options are directly cancel out based on my this example. Now limit of the an will goes to the 0. This is given. What does it mean? That is bn minus 0 is less than epsilon. And since it's a sequence of the positive number, so bn is also positive. Bn is less than 0. Then your targets to prove an will goes to the 0. Assume that an does not goes to the 0. That means an will be greater than of the 0. So I can apply it by the definition. There exists epsilon such that mod of an will be greater than epsilon, because an is my positive, so an will be greater than epsilon. That means the maximum of the ai's will also be greater than epsilon. That implies what is a bn? Bn is also greater than some number epsilon. That means this is the contradiction to the given fact. Hence an will goes to the 0, correct option. Now look at the third option. If bn converges to the half, that means an over this maximum value, I can choose maximum value is mn, minus of half is less than by the definition. Now what is the cases for the mn? But I have chosen mn is maximum of a1 to an. You have the two cases, either this cases is my bounded or this maximum is my unbounded. Because it's a maximum of them, it is always be my increasing or constant. That means is either a bounded or a unbounded. If this is bounded, I can assume mn is my alpha. It's a bounded. So therefore this sequence an over alpha minus half is less than epsilon. This implies I can multiply by alpha. So it's a alpha over 2 is epsilon alpha. Epsilon alpha is called as a epsilon dash. What does it mean? That means an converges to alpha over 2. Fine. Now look at the second side. If Mn is my unbounded, that means Mn will goes to the infinity. If Mn will goes to the infinity, what will be my Bn? This is my Bn. Bn will goes to the 0. But it is already given that Bn converges to the half. So this case is not possible. That means only case is An converges to alpha by 2, and it is a bounded. That means this is my finite limit. Hence the limit of An will be finite. So the right answer is C and D are my correct answers. For more detail about that, you must always start from these cases and watch about my this PY question series. Okay, look at this another one. F is a function which is defined like 1 over 1 minus x. Pn is a function which are the following statements are my true. First option, F is a uniform convergent or not. Fine. What is the definition of the uniform convergent? Fx minus fy is less than epsilon whenever x minus y is less than delta. Now clearly say, if you look about that, if I choose x and y which are very near to the 1, then definitely the difference of them will be satisfied. Fine. But what is the fx? Whenever x approaches to the near to the 1, this will be very large number. Fy will also be the very large number. Then the difference of them will also be very large number. That means it can never be less than of epsilon. So therefore the function is my not uniform continuous. The first option is the correct option. Look at the second one. The sequence Pn converges to the fx pointwise. What is the definition of the pointwise convergent? Limit n approaches infinity of the Pnx. So what is the limit of the Pnx? What is the value of the Pnx? It's a GP series. A 1 minus r raised to power n over 1 minus x. Now clearly say x belongs to my closed interval 0 comma 1. What does it mean? X raised to power n will goes to the 0. So therefore this quantity is, and it is again my fx, and this limit is existence. So if limit is existence, that means Pnx converges to the fx pointwise. That option is also the correct option. Look at the third option. The sequence Pn converges to the fx. Always remember, when you code as a sequence convergent, then you have to apply the Mn test. That means the supremum of Pnx minus fx. Fine. What is the domain is? The domain is open close interval 0 comma 1, and your target is to prove if this goes to the 0 as n approaches infinity, then it will be convergent. Now you can see supremum Pnx is 1 into 1 minus x raised to power n, fx is 1 over 1 minus x. Now if you open this bracket, it is my xn over 1 minus x. Fine. Supremum of x belongs to the 0 comma 1. So clearly say this limit will goes to the infinity as x approaches to the 1, because we are talking about the supremum. So therefore it does not goes to the 0, hence the sequence is not uniformly convergent. Look at the second option, last option. In the last option again they are talking about the uniform convergent. The only case is it will be my 0 comma c. Fine. So that means it is talking about the 0 comma c, and the value of the c is lies between open interval 0 comma 1. So that means c can never goes to the 1. So this value will be c raised to power n over, and it goes to the 0 as n approaches infinity, because c raised to power n will goes to the 0. So yes, because mn will goes to the 0, hence it is my uniform convergence. So the right answer is A, B and D are my right answers. You must watch about my this lecture for more detail about this uniform convergence. Now let again it's a sequence, so I can start with this 4 cases: constant, n, sin n. Out of that, which one is the bounded? So this is not a bounded, this is bounded, this is bounded, this is bounded. Limit does not exist. Constant always limit exists. Limit does not exist. Limit does not exist. Fine. So that means I have to take on the two cases. If I choose minus 1 raised to power n, limit does not exist, satisfied. Collection of all those L so that the subsequence converges to the L. You have the subsequence of minus 1, 1, 1, minus 1. Fine. You have the subsequence of 1, 1, 1. So what is the value of the L? L is either minus 1 or plus 1. So what is my S? S is either minus 1 to minus 1 or plus 1. S is empty, cancel out. S is exactly one element, cancel out. S is at least two element, fine. S is a finite set, fine. Now, if I choose the second example as a sin n, fine. What is the subsequence, or you can say what is the limit point? Limit point is closed interval minus 1 comma 1. So the S will be my minus 1 comma 1, because what is the L? L is basically the limit point. Fine. So what is that? How many points are there? It has infinitely many points, but he said finite point. At least 2 points. Yes, fine. C is my correct answer of this problem. Remember, this is a related to the part C, but only one correct option answer. Again, as I mentioned you must watch about my this sequence so that you can try to understand how you can attempt the question. The most important thing is how you can attempt the question. That's why I'm asking you. Your reaction will be changed from oof to wow once you are watching my this PY question series. Now, the series AN is my convergent. What does it mean? By the definition, limit n approaches infinity of an will be my 0. Define the sequences. The sequence is defined to you. Then which of the following statements are my necessary true? Okay. An goes to the 0. Look at the first option. Sequence will goes to the 0. When the sequence will goes to the 0? When you find the limit as n approaches infinity, if it is 0. Now let's start with this one. What is the limit of the an? So limit of an, this is already 0. What is the limit of the an? 0. So that will be my 0. So an goes to the 0, right answer. Similarly, bn will goes to the 0, right answer. Look at the second option. An is my absolute convergent. That means this is my absolute convergent. Then the series. Now you are talking about the series. So what is my series of an? Now your target is absolute convergent. Let's start with this series. What is that happening? This is my an. Whenever an is greater than 0. So and this is already absolute convergent. So therefore series an is also absolute convergent. Similarly, bn. bn is again a of n whenever an is my less than 0. So this is also absolute convergent. Yes, this option is also correct option. This is my convergent. They are not talking about the absolute convergent. If the series is convergent, then their subsequence, the sub-series is also convergent. I think that's not true. If I consider this series, clearly say this is my convergent by using the Leibniz test. What is my an? An is my 1 over n. Bn is my minus 1 over n. Fine. Then this series an is my divergent by using the p test. This series is also divergent by the p test. So third option is cancel. Look at the last option. Series an is not absolute convergent. What does it mean? That means series, because series an is convergent but not absolute. What does it mean? This is conditionally convergent. Fine. Now, as it is given that series an is convergent, and we already proved that in the third part, series an, series bn can never be convergent. What does it mean? That means it is my divergent series. Both are my divergent series. It can never be oscillating because it is already a conditional convergence. So the right answers are A, B, D are my correct answers. If you want to do more practice on these series, you have to watch about my these lectures. Okay, look at this is the function that's a very simple one. That's why I'm putting this picture for you, because your reaction will be look like say this one. It is x square when x is greater than 0, x is equal to 0, 0 minus x square, it is fine. Now if you draw the graphically, when x is greater than 0 it's a parabola, x is less than 0 it's a parabola. So clearly say this function is my continuous, this function is my differentiable for all x belongs to the R. So fine, fine, continuous, differentiable only at 0, wrong, not differentiable. So that's the right answers are my A and B are the correct answers. This is the first method, you can do it graphically. But if you want to use as a mathematically, how you can prove that? So clearly say y is a continuous because it's a polynomial. Fine. Every polynomial is a continuous function. Whenever x is my greater than 0, what is my fx? Is my x square. So it is a polynomial. Therefore, it is differentiable. So clearly say the third option, only differentiable at 0 is again cancelled out. Now, whenever x is less than 0, again the function is my minus x square, which is polynomial, so it is differentiable as well. Now you need to check only at the limit x approaches 0 negative, limit x approaches 0 positive. So what is the definition of the limit? What is the definition of the differentiability? This case. So let's start with this one. Limit x approaches 0 negative or 0 positive. When x approaches 0 negative, what is the fx is? Minus x square minus 0 over x. So what is the limit of this is? Minus x, that is a 0. Similarly for this case, when x approaches 0 positive, then your limit will be x square minus 0 over x, that is x which is 0, and you can see both are same. So yes, this is differentiable at x is equal to 0 as well. Greater than 0, less than 0, 0. So again the right options are A and B are the correct answers. Okay, now look at that. Now they are talking about the continuity. Very simple approach. As when what you have learned from this lecture, whenever the function is given as a continuous, you always start from the e raised to power x, or you can start with the constant function, or you can start with the linear function. As I mentioned you, whenever you have a sequence, you can start from -1 raised to power n and constant and the sign of n, and then discard the options. Similarly, whenever you will see the question related to the continuity, you always start from these cases. Fine. Now look at that, which cases will satisfied? Continuous, satisfied, 1 1. Clearly say constant function is not a 1 1. Fine. So that means I can choose either the e raised to power x or linear. So let's say I can choose a function fx is my linear. Fine, which is continuous as well as 1 1 from R to R. Now which are the following are necessary true? Increasing, decreasing. What is f dash? 1 greater than 0, not a decreasing because it implies increasing. However, if I choose a linear function is my minus of x, what is f dash? -1, which is my decreasing function, so it is not necessary increasing. Fine. Is it onto? Yes, it is onto. But if I choose the example as e raised to power x, fine, clearly say this is my not onto. So this option is cancelled out. Again, this function is my greater than 0. So either increasing or decreasing is the right answer of this problem. Again, you can see that based on this single 3 lines, you can get your answer in a 10 second. That's why I'm asking you, your reaction will be hooray. Okay, look at this another one. This is related to the improper integral. And if your reaction again will be look like say, oh, how you can solve that? Believe me, this is one of the easiest approach if you watch already my this lecture of the improper integral. This lecture is already available in this playlist. You can see if I write for you as an improper integral. Bounded variation, Bobby's transformation, identity theorem, all are available in this playlist. How you can solve that? Once you can solve this, your reaction will be look like say wow. So first of all, I will look about these third and fourth option, I of A. Convergent for all A and not for the A. So let's start with the A is equal to 0. Fine. What is your I of A? 0 to infinity, 1 over x into 1 plus x square. Now clearly say this component is my proper integral over the domain 0 to infinity, because this value will be my either 1 or 0. That's a finite number. The only quantity 1 over x has an improper integral at a 0. Fine. So what you can say about that? I can say this value is less than or equal to 1 over x. Fine. From 0 to infinity. Now clearly say this series is my divergent by the p test. Fine. So therefore, whenever a is equal to 0, this series is my divergent. And he said convergent for all, not for a. Fine. Convergent for a is equal to half. So when you take a is equal to half, then your IA will be 1 over x into 1 plus x square. Now clearly say this quantity 1 over x, 1 plus x square will be finite when a is equal to half. This quantity is also finite when this limit is my infinity. Fine. So that means this integration is my proper integral. So once this is my proper integral, the answer will always be my finite. So yes, this is my convergent at half and not for the 0. Now look at the first case. Since it is involvement of the sign, so I can convert into the polynomial terms. I can choose sin x is my y, then x will be my sine inverse y. Fine. So your I will be integration 1 over root y, sine inverse is 1 minus y square of dy. Sine pi by 2 is 1, sine pi is 0. Fine. I can take it as a negative common so that the limit will be 0 to 1. Fine. It is y 1 minus y square. Now which one is the improper? When you taken as a 0, this quantity is my improper. When you taken 1, this value is my improper. Fine. Now again you can see about that. I can break this value. If you want to break this value to be 1 plus y, 1 minus y. So clearly say for both the cases 0 and 1, this value will be my finite. Fine. So I can say this number will be less than or equal to, fine, because this number is always my finite from 0 to 1. Fine. Now this value, which things come in your mind when you look about 0 to 1? That's a beta function. So what is a beta function of this case? It is my beta of half. And what you know that what I told you in this shortcut tricks, beta function is always convergent for all these values of the m and n which are strictly greater than 0. Now if you look about that, the what is the value of the m? M is my half, n is my half, both are my greater than 0. So this series is my convergent. So the lower part is also my convergent. So yes, I is my convergent for here. So the right answer is A and C are my correct answer of this problem. I recommended you can watch more this lecture to understand this concept more deeply. Again, you can see the function is continuous. So you can start with e raised to power x constant or linear function. Which one of them will satisfy my this property? E raised to power x satisfied, x satisfied. Constant? No. Now look at that. Whenever x minus y is less than or equal to fx minus fy, what does it implies? Clearly say f is 1 1. Fine. Because if you assume that f of x is equal to fy, what will happen? X minus y is less than 0. That implies x is equal to y. So this case implies f is my 1 1. Now look at this case, which one is a continuous, which one is 1 1. So constant is not satisfied, exponential satisfied, x is also 1 1. Now k is a subset of the r. So if I choose r to r and f of x is my e raised to power x. So clearly say f is not onto, and look at the first option, need not be onto. Yes, this option is the correct option. Second option, f is onto if k is my 0 comma 1. Fine. Always remember student, you have to think only this condition. Fine, nothing is given to you, so that means all these options you have to discard or correct them based on this inequality. Now f is continuous, f is given as a continuous. Also, what can you say about 0 comma 1? This is my compact set. Fine. This is my connected set. Fine. Now once this is my connected, f is continuous, what does it mean? Image of the connected set on the continuous map is also connected set. Fine. Now, but we all knows on the real line R, what is the connected set? The connected set are only my intervals. Fine. The connected sets are my only intervals. So therefore, the image of this connected set is my interval a comma b. Is it fine? Now, in order to prove, or disprove f is subjective, what will be your target? Your target is to prove f of 0 must be 0, f of 1 must be 1. Fine. Now that's simple. Again I can use this inequality for all x and y belongs to the k. This is my k. For all I can choose x is my 1, y is my 0. Then this inequality becomes 1 minus 0 is f of 1 minus f of 0. Now because this is my connected, fine, the image will lies between 0 to 1, it is given to you. So the difference will always lies between 0 to 1. Fine. So what does it mean? The left hand side is also 1, right hand side is also 1. That means f of 1 minus f of 0 will be 1. Fine. And we have seen that f is my 1 1. What does it mean? F of 1 is not equal to f of 0. So the only case will be happening here is f of 1 will be 1 and f of 0 will be 0. So what does it implies? That means f is my onto is the correct option. Look at the third option. F is my 1 1. F inverse is continuous. F inverse is not continuous. Okay. Again we can use this inequality. First of all, you can look about f inverse. F of k to k. Fine. I can choose any two elements from the f of k. I can choose any two elements. Fine. Is it okay? Now, one f is given to my this. Fine. What does it mean? In this case, x and y are the elements of k. So that means f of x, f of y are the elements of the f of k, because k is my not onto, f is not onto only when it's a 0 comma 1. So that's a very simple. If I choose x, because f of x is, if I choose f inverse of a, y is my f inverse of b. So clearly say both the elements are belongs to my capital K. Fine, because a and b are the elements of the fk, f of x and f of y are the element of the fk. So I can choose this. Now again I can apply this definition on this case. So what will happen? F inverse of a minus f inverse of b, which will be less than of a minus b. What does it implies? What does it implies? That means f inverse satisfy Lipschitz condition. That means F inverse is my uniform continuous. This implies F inverse is my continuous. So the fourth option is cancelled. Third option is the right answer. Make sure student you have given this condition. So that means all these options have to prove in the similar manner. But I have one more method come in my mind. What is the definition of the continuity? If I choose the sequence yn converges to the y in f of k, fine. Then how you can prove the continuity? How you can prove the continuity? If I prove that f inverse of yk will converges to the f inverse of y, that implies f inverse is my continuous. Fine. So how you can think about in this manner? Again, very simple. I can choose again this inequality. Fine. I can choose yn to be f of xn and y to be f of x. Fine. Such that xn and x are the element of the k. So I can apply this definition again. So this will be xn minus x, which will be less than equal to f of xn. That will be my y. Fine. Yn minus y, and it goes to the 0 in the fk. What does it mean? Xn converges to the x. So what is the value of the xn? F inverse of the yn converges to the y. So again f is my continuous. So the right answer is A, B, C are the correct answers. Now look at this another one. A function of the several variable is given to you. Okay, so your target is to find the partial derivative at x is equal to 0. So I can start with the x comma 0 minus 0 comma 0 divided by x. So in this case, y is my 0, x is non-zero. X is non-zero, but y is 0, the limit is 0. X is my 0, x is my 0, limit is 0. So fx will be my 0. So limit exists, fine. Similarly, if you taken as a partial derivative with respect to y, so this limit will be 0 comma y minus 0 comma 0 over y. So clearly say when x is equal to 0, this limit will be 0. When x is 0, this limit is my 0. So again the limit is 0. So partial derivative existence. Now f is differentiable or not. So I can start with the differentiability definition. H comma k minus 0 comma 0 divided by h square plus k square, which is equal to h into partial derivative with respect to x plus k partial derivative with respect to y plus a function of h comma k. Fine. Now this value I have obtained from the first case is my 0. Partial derivative, this is also my 0. I can substitute the value of this. It is h over k, no sorry, k over h into h square plus k square, because first component x is 0, the answer is 0, divided by h square plus k square. So that means h over k. Now can you find the limit of h comma k which goes to the 0 comma 0? So definitely it will be my m. Sorry, it's a k over h. Fine. If I choose the path is m is equal to kh, then it is my dependent on the m. So that means limit not exist. If limit not exist, that means the function is not differentiable. The function is not differentiable. If the function is not differentiable, what does it mean? The function is not continuous. So all A, B, C, D are my right answer of this problem. For more detail about the function of the several variable, you must watch about my these PY question series. Make sure students you have to subscribe, like and comment on my videos, and you must watch about my these lectures so that you can get more confidence about this lecture series. Now I hope I have uploaded the solution of the July 2024 of all these topics in this playlist. Now I assume that your reaction will be of to wow and your confidence level will be increased. Don't forget to like, share and comment on this video. Best of luck students. Happy learning always.